Learning SQL commands on a whiteboard will only get you so far. To actually learn data engineering, you need a live, functioning database on your own machine to manipulate and practice on. In the next 6 minutes, we will populate a local database with thousands of rows and columns of customer data, accessible directly from your desktop. We have 3 specific requirements to proceed. You need a Windows PC, an active internet connection, and the provided .SQL initialization script found in the course materials. Setting up this environment removes the primary technical blocker to learning. Once these 2 components are connected, you have a sandbox to test and execute the code used in professional data engineering. A local SQL environment requires 2 separate pieces of software. First, an invisible engine to store data, and second, a control interface to send commands. We'll use Microsoft SQL Server Express as our engine. It provides enterprise features, streamlined for local development. When you run the installer, select the basic pathway. This avoids the complex configuration steps required for remote or multi-user servers. Once installed, the engine runs silently as a background process without opening its own application window. To interact with it, we need our remote control, SQL Server Management Studio, or SSMS. It provides the graphical workspace to write and execute code. You can find the download link for the SSMS setup file directly on the finalized SQL Server Express installation screen. Run the downloaded installer using the default location in settings. Without the server engine, there's no data to query. Without SSMS, there's no way to send commands. Having both installed completes the local architecture. Our next step is to link the SSMS client to the server engine. Open SSMS and a Connect to Server window will appear. The most common connection error happens here, at the server name field. SSMS needs to know exactly which local instance to target. If the field is empty, open your Windows command prompt, type "Who am I?" and press Enter. This returns your specific PC name and user account. Typing this exact string into the SSMS server name box will bridge the gap. Before clicking Connect, ensure the encryption is set to mandatory and check the box for Trust Server Certificate. This overrides the default blocks on local connections. Click Connect. If the Object Explorer hierarchy populates on the left side of your screen, your local server is live and reachable. Navigating these naming and certificate protocols provides you with full administrative access to your local data environment. At this stage, the server is a functional but empty container. We need to populate it with actual information. Open the .SQL initialization script provided in the course materials. In SSMS, click New Query in the top ribbon. This opens a blank text editor window where we can run raw SQL code. Copy the text from the initialization script, paste it into the editor, and click Execute. This script builds the internal table structures and inserts several rows of data automatically. The Object Explorer will not update on its own. To see these new tables, right-click the Databases folder and select Refresh. Navigate through the Databases folder into the Table subfolder. You should now see an object titled Customers. To verify the data is inside, right-click the Customers table and select Top 1000 Rows. SSMS will generate a query and display the records in the results grid below. Seeing these rows confirms that your local machine can now successfully store, process, and retrieve structured data. You now have a functioning server environment with a results grid displaying live data. This is the exact same suite of tools used in enterprise data departments to manage massive scale warehouses. The infrastructure is now in place. We can now shift from building the lab to writing the logic, starting with independent select queries. With your local laboratory fully equipped, you are ready to begin analyzing real-world data.